Hi, we are the Cocktail Party, and for our junior design project, we are working with AudioT to develop Label Me Audio, an audio labeling web app to create labeled datasets to train machine learning models on poultry vocalizations. In today's rapidly developing world, we see a rise in population and the general quality of life. With this comes a demand for more nutritious food, and as one of the cheapest sources of protein, poultry faces an especially high demand. As throughput at poultry farms increase, so will the difficulty and cost of managing them. And with the rise of the Industrial Revolution, we saw the rise of factory farms. But with today's proliferation of machine learning and the Internet of Things, we are at the bleeding edge of yet another revolution. Routine tasks that are traditionally performed by humans can be relegated to machine learning models that not only reduce human effort but also increase the efficiency and accuracy at which such farms can function. And with such large concentrations of birds, we create the perfect breeding grounds for disease, allowing disasters like the recent outbreak of avian flu to occur. Diseases can also only be intervened when they've spread enough for workers to detect them manually, which is usually already too late. Machine learning models, however, can detect the presence, spread, and even allow tracing disease with significantly higher accuracy and speed, allowing for better interventions. Placing a microphone at each flock in a broiler house and deploying a machine learning model to track the frequency of coughs, clucks, or other vocalizations would more accurately alert workers to certain flocks, which would reduce the rate of spread. In addition, additional insights such as the position of the flock and the spread pattern among different flocks and similar data can also allow workers to identify leaks into the broiler house to see where diseases may be coming in from, further compounding the benefits from such a system. However, there currently exist no labeled datasets of poultry vocalizations, let alone machine learning models that are trained for such an application. As such, AudioT has ventured to create Label Me Audio, a web app to quicken the process of creating such a dataset. Labelers can import audio that AudioT gathers from microphones placed at broiler houses, label them, and export the labeled audio. And as accuracy in labeling is key, a range of playback features are made available to users. Specific features, such as displaying a spectrogram, will also enable labelers to engage their vision, in addition to hearing, in learning different vocalizations to be able to label them more accurately. And given the novelty of such an application, AudioT has attracted the investment of companies that heavily rely on chicken farms, such as Tyson Foods and McDonald's, signaling the market value of the project. And broiler houses have much to save on human capital and preventing the unnecessary loss of livestock. And though the machine learning model might only be functioning from audio that streams from a broiler house, the benefits from such insights go much beyond. Integrators that purchase poultry products to distribute to the market, such as Tyson, can ensure compliance with animal welfare policies and can also better define the best practices of poultry farming and survey broiler houses to more accurately make investments. And retailers such as McDonald's also stand to gain from a lower price of purchasing raw goods and also marketing the benefits of better animal welfare.
For more about our client, Tom Darbon, who is the CEO of AudioT. He has been specialized in the intersection between computing and audio data for well over 16 years, and currently he's working with AudioT, which is still in the startup phase, to develop methods to asynchronously monitor chicken flocks through audio. For instance, how to monitor well-being, as was talked about earlier when we mentioned the huge significance that this project can have. So for the users of this project, because we were just making the system to help label training data for the AI, we just have to focus on data labelers, which are a small group of users. And that means, since they are such a small private group of users, we can focus less on accessibility and scaling, but focus more on each individual labeler's needs. For instance, each individual labeler needs to be fast and efficient when labeling data. They need to be able to cleanly read the audio so that they can label it extremely fastly and move on to the next audio file. And we have to prioritize how accurate their labeling is. We want to minimize risk that stuff is labeled falsely.
In our secondary research, we found one study where an AI was able to detect traces of bronchitis in a room of 20-30 chickens. Now, for this small sample size, there were still misclassifications. And so we want our product to be able to generate AI that could dictate sounds of distress for farms of thousands of chickens. It shows that our labeling tool needs to be super accurate. Luckily, it's still feasible for that kind of accuracy because sounds of distress are commonly of higher frequencies. So we can use our eyes and our ears to help create those labels. Now, unfortunately, that level of accuracy is difficult because of some user unfriendliness in the current labeling tool. The way it works is that you drag this blue cursor to the right, and that helps zooms in on the spectrograph. And these red bars are the labels. And some of the current issues that our users reported were that these opaque bars, their opaqueness makes it difficult to see the spectrograph. Also, as you can see, there's no numerical markings for the degree of zoom you're doing or how long the audio clip is. Other comments users made were that in order to actually see that a label has been saved or is reviewed, you need to export the file and then re-import it, and then these opaque red bars will turn yellow. And then other reports were that the resolution was blurry. Lastly, once you click on a red bar to make a label, there will be a drop down. And another comment users reported was that clicking save to make an audio label was was not as intuitive. So because the user interface is not that intuitive, our first design sprint was focused on making sure that the user interface was more intuitive for our users.
For the tech stack, we decided on a React frontend due to its large community for documentation, its focus on web app support, and the fact that many of our developers are experienced with the platform. Not to mention that it is also active in the current code base for the project. For the backend, we decided on Python due to its simplicity, which makes it easy to update and maintain, and its wealth of extensive libraries for implementing features like audio players. Finally, for our database solution, we settled on AWS. AWS is a secure cloud framework that can store our audio data and access it from the web app. It scales easily, is widely documented, and is already supported with the client's current architecture for the project.
Now, I would like to share some important lessons that we learned throughout the semester. At first, we had difficulty communicating with the client. Suddenly from week 5, we couldn't reach the client for about 2 weeks, and we couldn't even start the lo-fi prototype. During the time, we thought about and planned what we could do immediately, and also continued to try to contact the client. In the process, we gained stronger teamwork and realized the importance of communication with client. After that, we had about 5 assignments to complete in short term. By working together and dividing the workload based on each team member's strengths and preferences, we were able to complete the assignments successfully and keep up with the course steps. This experience taught us the importance of appropriate role delegation through communication. We also learned that using collaborative tools such as Teams, Microteams, and Slack can help maintain organization and improve productivity. Using these tools allowed us to track project progress, assign tasks, and communicate more effectively.
Let's have a look at some of the new UI UX features. Returning users will be pleased to find we have forewent the pair of pause and play buttons for one pause play button, more reminiscent of traditional audio players while decluttering the interface. Moving on to labeling, new users will be greeted with the guide text on top describing how to select a label range. Simply drag across a region in the spectrogram and click to open. Then add a new label, which you will see in the label editor once saved. We have also added a playback speed slider in the bottom right to speed up and slow down audio playback as needed. In the future, we plan to refine the scaling features on the spectrogram and make existing labels more visible for the users on the spectrogram. But that wraps up this quick demonstration, and we look forward to your feedback. Thank you.